In today's lesson, we're going to focus on two things. How to calculate the value for the circumference of a circle, and then how to calculate the length of an arc. So first, let's talk about how to find the circumference. So just a quick review, the circumference is going to be the distance around the circle one time. So let's say I start here and I take a lap around the circle. That distance to go around the circle one time is the circumference. Okay. So there's actually going to be two formulas that you'll see when we're calculating your circumference. And what you're going to have to do in problems that deal with the circumference is decide which formula out of the two that you're going to use. Okay. So here's the first formula. I can find the circumference, which is represented by C. I can find the circumference if I take the diameter, so that's D for diameter, and I multiply it by pi. Okay. So the diameter, we'll put that here. So D represents diameter, where C is circumference. Okay, there and there. So if you remember, the diameter is the distance from one end of the circle, has to go right through the center, and then connects to the other side in a straight line. So that would be the diameter. So if I know what it is, and I just multiply that by pi, then I'll have the value for the circumference. The other formula that we can use for circumference is if we use the radius instead. So if I did 2 times pi times r, and r represents the radius, that's another way to find the circumference. Okay. So recall that the radius is half of the distance of that diameter. So that would be the radius there. So if I take the radius and if I multiply that by 2, if I make 2 of these, which is the same as the diameter, so basically I just took this here, 2 radiuses make 1 diameter, and I'm still multiplying that by pi. Okay? So those are the two formulas. Let's test them out right now. So again, the goal is to figure out which one of these two am I using depending on the problem that I'm given. So for the first one, it says find the circumference of a circle with a radius of 9. So since it mentions the word radius, okay, radius is going to lead me to use this problem. Okay, just because this one, it doesn't talk about the radius at all. This is the formula that has to do with the radius. Okay, so I'm going to write C equals 2 pi r. I put them all next to each other, and I know that I'm still multiplying them together. Okay, so since it has a radius of 9, where r is, I'm going to go ahead and replace that with 9. So then I'll get circumference is equal to 2 pi, so 2 times pi times, and then I'm plugging in for the radius a value of 9. So 2 times pi times. So every time that I see pi, in any of these problems that I'm going to do, we're going to approximate pi, because pi, if you know, it actually goes on forever. So this just represents a number that goes on for infinity. But we'll just replace this with 3.14. Okay, so we can use that to easily calculate these problems. So then I would get that the circumference is 2 times, replacing that with 3.14, times 9. Okay, so then I can easily put all of that into the calculator. So 2 times 3.14 times 9 gives me 56.52. Okay, so every time that I see pi, I'm going to replace that with 3.14. All right, on to the next problem. So now we're going to find the circumference of the circle. It has a diameter of 8 meters. So as you're guessing, we're probably going to use this first formula because this is the one that mentions diameter. So I'll write that circumference equals diameter times pi. And then I know the diameter is 8 meters. So in for D, I'm going to plug in 8. And then I'll take pi and replace that with 3.14. So then if I do 8 times 3.14, I get 25.12. Okay, so that's the value for my circumference. Just as 56.52 was the value, that was the distance around the circle one time for that circle. That was the circumference. Okay, and then the last problem that we'll do is a little bit different. So this one says find the radius, not the circumference. It says find the radius of the circle with a circumference of 20 miles. Okay, so I'm still talking about the radius and the circumference, okay? So I want a formula that has to do with both the radius and the circumference, which would be this second formula here. So I'm going to go ahead and write this down. And then if I'm paying really close attention to what it says here, I'm trying to find the radius, okay? That's what I want to find. And it's of a circle with a circumference. So now I know the value for the circumference. They calculated that for me already. So the circumference is 20 miles. So where do I put this number 20? Where do I plug it in? So since I know that this is the circumference, I'm going to take 20 and plug that in for C, because C represents the circumference. So I'll write this as 20 equals 2 times, and then I'll change that to 3.14 times R. Okay, so that's what it looks like, a little bit different than the last problem, so just pay close attention to what it's telling you the value of, whether that's the radius, the diameter, or the circumference, and it's going to tell you where to plug this into your formula. So then, if I multiply, I'll bring the 20 down, and then I'm going to multiply 2 times 3.14, and I get 6.28 multiplied by R, okay? So at this point, I want to get them separated. I want to get R all by itself, so I need to do the opposite of multiplication, which is division. So I divide by 6.28, do that to both sides. So doing that is going to get the 6.28 to cancel completely. And then to find the value of R, here, R is just going to be whatever 20 divided by 6.28 is, which is 3.18 if I'm rounding to the nearest hundredth or 2 decimal places. So 3.18. So that would be the length of the radius for this circle. Okay, so there are all the problems that have to do with circumference. The other thing that we're going to cover is arc length. Okay, so before we talk about that, we're going to quickly just kind of run through some vocabulary and talk about what an arc is. So we just remember that from the very first lesson, an arc is a piece of the circumference. Okay, so if our circumference is the whole distance around the circle, an arc is just part of that distance. It doesn't go all the way around. It just stops at some point, okay? So then, if we're going to distinguish between these two things, and the measure of the arc is the same, and we've talked about arc measure before, the arc measure is the same as the measure of its central angle, okay? Measured in degrees. It is a piece, hold on. Is a piece of the 360-degree measure of a circle. So recall that arcs can be measured as minor arcs, you can have semicircles, or major arcs, okay? And that all has to do with their arc measure. So that we've learned before about minor, major, and semicircles, okay? So here, just a quick review from stuff that we've learned before. Remember that if we have our central angle here, let's say this was like 30 degrees, then the measure of the arc, so if I was to measure this arc that's out here, that would also be the same thing. That would also be 30 degrees. And I'm measuring this in degrees, how much it rotates, how much it turns, okay? Arc length is going to be something completely different, okay? So instead of this being measured in degrees, because both of those are in degrees, arc length is a distance, okay? the distance of the arc. How long is the arc? Actually, so it's a piece of how long the circumference is. So I actually want to know if I was walking from point A to point B, how far was that? What was the distance of that? How long is this length there? So maybe I say that this is 20 inches or something like that. It's a length where this is measured in degrees. Okay, so that's the difference between the two. So here's the formula that we're going to use to calculate arc length. So it's going to look like this here. So arc length, I'll get that if I just take 2 times pi times r. Hey, which that looks really familiar, right? Like that's our formula for circumference, okay? So 2 times pi times r, and I multiply that by the central angle, okay? Whatever that angle is here, that has to do with that arc I'm trying to find, okay? And I divide that by 360 degrees, okay? So that's going to give me just this piece of the arc length. So let's go ahead and try that now. So we're going to find the length from B to D. So what's the distance from here all the way to here? How long is that arc? Given that BC, so that distance there, given that BC is 5, and the measure of angle BCD, so that would be this angle, is 95 degrees, okay? So I have everything that I need right now. I'm just going to plug it into this formula. So arc length is going to be equal to 2 times, and I'm going to change this pi to 3.14, so 2 times 3.14 times, and then remember the r represents the radius. So what is the radius in this picture? That would be the 5 that they gave me. That's the radius of the circle. So 2 times 3.14 times 5, and then multiply that again by the central angle. So the central angle in this picture is 95 degrees. So multiply that by 95 degrees, and that's divided by 360. So that 360 is always going to be there. Okay, so I have everything plugged in that I need to. I just put all of this into the calculator. So first what I would do actually is just put this entire thing into Desmos at once to avoid making any little tiny mistakes. But I'm going to do 95 divided by 360, and then I'll multiply that by 5, multiply that by 3.14, and then multiply that by 2, and I'm going to get 8.28, and then 6 comes after that, so I'm going to round this to the nearest hundredth, so this will be 8.29, okay? So that would be the length of the arc. Let's say this is, we'll be more specific. So this is the length of the arc, BD, specifically BD. Okay, so we'll do one more example of this. So now in this problem, we're going to find the length of BAD. So notice if it has 3 letters, that's when it's a major arc. So BAD is going to go this way. So it's a lot bigger arc we're trying to find this time. Now we're told that BC, or the radius, we're told that the radius is 3, and that the measure of BCD, okay, the measure of angle BCD is 100 degrees. All right, so I've filled everything in. This is what I have. So here we have our arc length. And I'm just using the formula from above. So it's going to be 2 times 3.14 times the radius. So I'll do that part first. So 2 times 3.14 times the radius, which is 3. And then this part gets a little bit different, so make sure you're following along with this. So I still have 360 degrees here, But my central angle is actually not going to be 100. I'm not going to put 100 here. And the reason why is because here, that central angle, that corresponded to the arc length, okay? This angle had to do specifically with this arc, okay? This angle here has to do with this arc, BD, okay? I want to know the angle instead that goes along with, so this angle instead, this bigger angle on the other side that goes along with this bigger arc, okay? So how many degrees would this angle be instead? Because that's the one that I want to divide by 360. Okay, so to do that, I know that the whole circle, if I measure it in degrees, the whole circle is 360 degrees. So if I take 360, subtract 100 from it, then I'll be able to find out that dark blue angle there. So that should be 260. Okay, so now I found the angle that corresponds to that arc that I'm trying to find. Okay, this one didn't. It would correspond to BD instead. So that's why I found this angle, this central angle. Okay. So now I'll take 260 degrees. I'm not using this one. I don't care about this one. I only care about this angle because it goes along with the arc that I'm using. All right, so now that I have everything, I know that the length of arc BAD is going to be equal to all of this. Don't worry about including the degrees there. Just as long as I have 260, I'm using 260 divided by 360. Multiply that by 3, and then multiply that by 3.14 times 2, and I get 13.6, and then I see 0.6 after that, so I'll round that up to be 3.61. So that would be the length of this arc if we were starting at B and we walked around this distance and we ended at point D. That's how far we would have to walk.